Get enough. What's going on? Hazelton from the 403. Mr. Nelson here. Okay, it's been a while since I've made a video. Let's catch up on quadratic. So we left off, last video was about optimization and minimization, optimization problems around completing the square. So quadratics, we've been talking about standard form, and which is also known as vertex, as far as I know. And then we have general form, Okay, and we've kind of discussed everything we need to know about how to interpret the different equations. Just as a reminder, the equation for a quadratic in standard form is y is equal to ax minus p squared plus q, where the vertex is at p, q, and we can figure out our y-intercept, which happens at x is equal to 0. So we can plug in 0 for x there and figure out what the corresponding value for y is. The x-intercept, we have to, which happens at y is equal to 0, we have to solve for. Now the next phase of the last phase of the quadratics unit is about solving what we call solving quadratic equations. And what that means is essentially just finding the x-intercepts. Solving, finding the roots, those are all different, finding the roots, solving, and finding the x-intercepts, those are all different ways of saying the same thing. I'm talking too much again. I'll get you there. So that's standard form, and then we have general form, where we have y is equal to ax squared plus bx plus c. And in this case, I don't know my vertex, I can't tell by just looking at it. I do know that my y-intercept, which occurs at x is equal to 0, will be c, because if this is 0, this is 0, all that I have left is c, so it's equal to c in this particular case. What else do I know? I know my x-intercept occurs at y is equal to 0, and I can factor this equation when y is equal to 0 to get my x-intercepts or my solution. So the reason I wanted to look at the two forms here is just to remind us that if I want to get from standard form to general form, I have to expand and multiply this equation. Okay, and if I want to get from general form back to vertex form, I have to complete the square. Okay, and just knowing how to interchange between these two is good to know how to do, because it unlocks different things. Because say for example I have this in general form and they ask me what my vertex is. Well, I could convert to standard vertex form and determine my vertex from there. We've already talked about completing the square, all that stuff. So let's quickly, actually we'll just leave it at that. So now the next phase of this unit, kind of where it's all leading, is to finding solutions. So we call the things that we're looking at now are the roots, aka the solution, aka the x-intercepts. These are all the same way of asking for the same thing. So We are doing this because as we move ahead in math, we're going to start working with multiple graphs. Okay? We'll start to have multiple graphs occurring on the same chart. And the solutions, we're starting to look for where these intersection points happen, where these two curves are equal to each other, because we can gather a lot of information from when those 2 points occur at the same place. And this is a hybrid of figuring out, well, if I had a curve like this is the same as finding the solutions at the x-axis. But we can convert this into one equation. I am getting so far ahead of myself right now. I'm going to get there. I'm getting too advanced. So I thought that this might happen with this particular video, and it did. It did. So take 2. Let's just talk. So root solutions, x-intercepts, they're all the same. So general form. When I'm trying to find my solution, aka my x-intercepts, I have a couple of options. Okay? So finding the root solutions or x-intercepts, which are all the same thing. Same thing. Okay? My option 1 is to factor. And from the factor, I can find the roots. So for example, if I factor something down and I get as my x plus 2, x minus 1, y is equal to this. Well, we're almost at the solution or at the roots, but to find the roots, I have to, because it's the x-intercept, I have to make y equal to 0. So I have x plus 2, x minus 1 is equal to 0. And then if I solve for each binomial, I get x plus 2 is equal to 0, and x minus 1 is equal to 0. Why is that? And then these would give me x is equal to -2 as a solution, and x is equal to +1 if I solve for x. Why is that the case? Well, if I were to go through, so if I had x plus 2, x minus 1 equals to 0, and I were to solve these, well, if I solved for x, I could get rid of this binomial by just dividing it out. 0 divided by that would be 0. So this leaves me with x plus 2 is equal to 0. That's one solution. And then if I did the same thing here, divided out this and left this, I would get x minus 1 is equal to 0. And then if I solve those, I get the solution. So that's my first option, is factoring. And when I'm factoring, I can either do the product sum method, and that's great for when I have an equation where I don't have a number in front of my squared variable term. So this is always 1 for the product sum, plus 3x plus 2, let's say. Okay? I can use a product sum. 2 numbers that multiply to +2 that add to 3. Those are 2 and 1. So I can rewrite this as x plus 2, x plus 1. Okay, and then I would know that my solution is x is equal to -2, x is equal to -1. But when I have a number in front of my x squared term, say like 3x squared minus 4x plus 10, as an example, this one might not work out, but now that there's a number in front of my squared term, I have to use the decomposition method to find my factors. Now there's a video about decomposition method in the next, below here. There's another video about that. I'm not going to repeat that video. So factoring, that's the first option, one of those 2 ways. And then the other option I have to find the roots, when I'm in general form, is to use something called the quadratic formula. Quadratic formula tells me that the roots x are equal to -b plus or minus the square root of b squared minus 4ac divided by 2a. This plus or minus tells me that I'm going to have 2 solutions. One is the plus scenario, when I add that root, and the other is when I subtract the root. That's what plus minus means. There are 2 different scenarios, 2 different realities, 2 different universes. So when I'm in general form, these are my 2 options for finding my solutions. Obviously I can always graph it as well, but we're not talking about graphing right now because that's too easy. So in standard form, or vertex form, when I'm of the form a x minus p squared plus q, I can do two things to figure out my roots. The first thing I could do is I could convert this into general form. And then I could use the, actually, so the first thing I could do is just to solve for x here. So, because we're looking at the x-intercepts, the solutions, roots are always x-intercepts, those occur at y is equal to 0. So I would get, and then I would have to solve for x. So what does that look like? Well, 0 is equal to a x minus p squared plus q, and then if I solve for x, I get negative q is equal to a, so I subtract this away, x minus p squared, and then I divide out the a, so I get negative q divided by a is equal to x minus p squared. And then I take the square root of both sides, so I get the square root plus or minus of negative q over a is equal to x minus p. And x then is therefore equal to, x is equal to p plus or minus the square root of negative q over a. This looks really complicated. Let's use actual numbers to see what this is. But again, I have two scenarios, plus and minus here. So, I'm using a sock today to erase. So, in a practical sense, so let's say I had an equation like y is equal to x minus 2 minus 16 minus 10. Okay? So if I'm trying to find the roots of this quadratic equation in standard form, I just have to solve, I have to make y is equal to 0 if I'm finding the roots, and I solve for x. So I get 10 is equal to x minus 2 squared. I just move this across. And then I take the square root of both sides to get rid of this square, and it's plus or minus. So I get x minus 2 is equal to plus or minus root 10. Now, why is it plus or minus root 10? Why is it plus or minus? Well, because this is telling us that I can either have two negative numbers, identical numbers, multiplied together to give me 10, or I can have two positive numbers, because the square root of 4 can either be negative 2 times negative 2, or it can be positive 2 times positive 2. So if the square root of 4 is plus or minus 2, right? Because I can do negative 2 times negative 2, or I can do 2 times 2. So the square root can be either two negative numbers or two positive numbers. So that's where we get this from. And then to finish it off, I would get x is equal to 2 plus or minus 10. So one solution is going to be 2 minus square root of 10, and the other solution is going to be 2 plus the square root of 10. And I could leave it in this form, or I could solve for a square root of 10 and see what it gives me. So that's the first way of finding the roots of an equation in standard form. Okay, it's just going through and solving for x. So 1 is solve for x at y is equal to 0, or when y is equal to 0. The second solution that I have, or the second option, is to convert this to general form and either factor it or use a quadratic formula and solve using either this or this. Okay, so we know how to factor. We've done this before in grade 10, and we know how to solve for x. So all we now need to learn is how to use the quadratic formula, which is basically like our silver bullet our werewolf Van Helsing hunter. Where did that even come from? I don't know. Okay. Nice brain. Van Helsing. Van Helsing. What is it? That is that Dracula? Doesn't matter. It doesn't matter. It doesn't matter. It matters. No, it doesn't. Okay. So this is basically what we're doing now. And solving for x becomes a big component of what we're doing moving forward. Now, I'm not going to get into that. Thank you for watching. We'll talk about quadratic formula in the next video.